Morning everyone, this is Papia Datta working as a lecturer in Devi Mahalakshmi Polytechnic College. Today we are going to perform exercise number 22 of applied electronics, that is high voltage regulator using IC723. So this is the circuit diagram and the various components used over here. So components used in this circuit diagram are digital multimeter, DC power supply, regulator IC, resistor, capacitor, breadboard and connecting wires. So if you look at this diagram, so this part of the circuit is used for obtaining pulsating DC or a variable DC that will be applied to the VCC as a VCC supply to the LM723. So this part is directly feeding from the DC voltage output obtained from a DC regulated power supply. So this is the now we'll talk about the pin configuration IC723. So this is unregulated VCC which is applied to the pin number 7. Next, reference voltage is connected to pin number 6. Next, which is near about 6.8 volt to 7.5 volt, and output voltage is taken from pin number 10, and we are connecting the external series pass transistor here. So these are the transistors. So here V plus and VCC, which is a ground, then reference voltage pin number 6, which is near about 6.8 volt to 7.5 volt, and here output voltage has been taken from pin number 10, and we are connecting the external series pass transistor over here. So let's move back to the circuit diagram. So this is a circuit diagram over here. So there are two transistors, BT135 and 2N3055. These two are internally connected. Now this is a resistor REC of 0.15 ohm per 5 watt. Then these two resistors are used as voltage divider wising. Here we will connect a variable load over here, where like potentiometer, and to measure current we can connect a milliampere, and to measure output voltage we are connecting a voltmeter over here across these two terminals. So same circuit is built on the breadboard except this portion. We'll build the remaining circuit on the breadboard. So this is a circuit. So here we have to take the this is an observation table where load resistance we have kept constant, which is 1 kilo ohm. Okay, so by varying the input voltage we will get the output voltage. So we have switched on the power supply where 10 volt DC power supply has been given to this circuit, and here we'll get the output voltage. So for input voltage 10 volt we are getting now we'll check for next 12 volt. For 12 volt it is 9.89. okay, here I have already taken the readings. For you people I am again doing the practical. Next, for 14 volt we'll check for 14 volt. It is 12.09. okay, here we got 11.83 earlier. Next we'll check for 16 volt. In the terms of 2, multiples of 2 we'll check. It is 13.43. next, if you can see 16, 18 and 20, it has a constant output. So likewise we have to calculate the input voltage and output voltage, and its line regulation can be calculated as delta V out, it is change in output voltage upon change in input voltage. We'll take the any two output voltage and we'll take the difference, and any two input voltage and take the difference, and depending on that we'll get the line regulation. Here 13.47 and 13.43, these two values I have taken. and input voltage we have taken as 22 minus 20 and we got 0.02. Now for load regulation, so it is the 0.02 upon 2 into 100. So this is the efficiency we have got. Now for calculating the load regulation, we that is no load voltage minus full load upon full load into 100. Okay, so no load, now load regulation is 0. Line regulation 0.5%, which is 0.01% of V naught, and load regulation is 0.6% of V naught equal to 0.003 of V naught. So this is for load regulation. Here we have to keep the input voltage constant, which is 16, and we have calculated the load current. Initially we have taken 0, 3, 5, 7, 9, 11, 14, 17, 29, and depending on that we got the output voltage. So here in this circuit, if you look at this diagram, we have to calculate the load current in the between the two terminals, across those two terminals. Okay, so here we have taken two multimeters over here. One will show you the voltage and one will show you the current. So initially I have taken input voltage given as 16 volt, which is constant, and here we have to vary the input voltage, and depending on that we will get the output voltage over here. I hope you have understood the concept of high voltage regulator using IC LM723. I hope you have understood the concept of this practical. Thank you.